All right, in section 10.8, we're talking about the natural log function. And the natural log function is something that you see it in a lot in nature. You see the mathematics of it in a lot of things in nature, earthquakes. We see it in a lot of things in business, a lot of business applications for it. You'll just see that things follow the shape of this curve. And what it really is a log base E, and E is a number. About 2.7. It's another number like pi that shows up a lot when you look at things that naturally occur. And so you could write it as log base E, but because it happens so much, they just call it LN because mathematicians don't want to write a lot, and that stands for the natural log because it's seen so much naturally. Okay, all right. So if you have trouble with this, what you could do is think of it, it's just a notation. You could think of it as log base E and rewrite it that way. And now if you do that, you can use all the techniques you've learned before. They want you to rewrite this in exponential form. This is a log form. So you could label this log A, B, C, okay? And if you're going to rewrite it in an exponential form, that would be I, C, a B. A to the C power is equal B. And then, so your A here would be E. If you look at, let's look at where we're going to pull these numbers from. Your base is E. Your base is always E. You don't really have to write log E unless you want to because you know your base is E. And then your C is 2.08. And then the B term that goes on the right is 8. So this is how you would rewrite that. So if you just redo it like this, it can be okay. Let's look at maybe number 3 also. 3 is ln a third equal negative 1.10. Okay, you could label this like this one over here and rewrite it, but this is base E. Okay, so if you just remember, ln is log base E. So if you remember, you take the base from the left, you go over to the other side of the equal sign. That's your exponent. And then the number that used to be in the middle of the numbers, we don't see the number here unless we write log base E for ln. The number in the middle is the thing that it's equal to. So this is how you would rewrite that one. Okay, now they want us to take this one and write it in log form. Well, if you need to label it, you can. You label this I, C, a B because it's an exponential form. And if you're going to rewrite it, it would be alphabetical logbook. Log A, B equals C. Now, you know that E right there is your base. And remember, that's the little A there. But if you didn't remember that, your A is E. So this is going to be log E. Your B is over here on the other side, 1.65. And then your C is the exponent a half. This is how you'd rewrite it, except that we don't write log base E. We're going to use the proper notation. You may need to do that first, but then just realize log base E is the same thing as ln. 1.65 is a half. For some people, I know for me, this was a harder thing to do, so I know that as I was learning this is exactly the way I did these problems myself. Okay, when you see a problem like this, the ln and the e undo each other, okay? So it's almost like they cancel out. This is just going to be 2. It's like saying log base e of e, log base e of e squared. Remember when these two numbers were the same here? Back when we talked about logs, they basically cancel out and you just get 2 as your answer. Because if you think about it, if you write this, just so you understand it, let's put a C over here. And let's rewrite this in exponential form. We could label this log A, B, C. And so it would be, if we change it to I, C, a B, it would be E to the C power is equal to E squared, because your B is E squared. And you could say, oh, well, the exponent is 2, so the answer is 2. So when you see these two things together, this is not really proper mathematics for me to do it this way, but it's as if they cancel out and you're left with the exponent of 2. What is the missing exponent? It is 2. Let's try another. All right, when you're looking at this one, you may go, oh, what am I supposed to do with this? But, think about how you could do this. This is an ln. E to the third on the denominator of a fraction with a 1 on top would just be e to the negative 3. And it's equal to negative 3. Duh, I wrote the answer up here when I did it. So we've got ln 1 over e cubed, so that's ln e to the negative 3. And just like on number 9, what's going to happen is these two things are inverses of each other. They undo each other. It's like having a square and a square root, and your answer is just going to be negative 3. Okay, so it's just like number 9, but you have to rewrite it first. So a lot of times, see if you can rewrite things first. And by the way, this is a skill we use heavily in calculus, so it's something you're going to see again. Let's look at number 13. ln 1, what is that equal to? Well, just remember, ln is log base e of 1, if you need to rewrite it, and that's equal to some missing exponent. Okay, well, that's log ABC if you want to label it, if you're having trouble thinking about this. And then you change it to I, C, and B. You change it to its inverse form so you can figure it out. A is your E, your C is your missing exponent, and B is 1. E to what power is 1? Well, do you remember that anything to the 0 power is 1? So what this is equal to is 0. Okay, now a lot of people kind of memorize this one because, you know, it shows up a lot. ln 1 is 0, but it's e to what power is equal to 1? It's 0. Okay, so you can always take these things and label them and figure them out that way. If you remember from number 9 and 11, e and ln are inverses of each other, and before they had it written as ln of e of something. Here it's e ln of something, but it's still the same basic idea. These two things undo each other. They cancel each other out. So this is going to be a 5 as your answer. If you had to rewrite this, you could. You could say, okay, let me prove to you that it is 5. You could say this is I, C, a B, and my B is missing, okay? So if I rewrite this as log A, B, C, that would mean my A is E, so this is log base E, which is ln. And then you've got a B. We just called it B. And then my C is ln 5. Okay, so log base E is ln B, right? This is just another way of writing it. It's just a notation thing. If ln B is equal to ln 5, oh, that must mean B is 5. You can figure this out the long way, or you can remember that these two undo each other and do it that way and have it done so much faster. In the problem set that starts with 17, that little block of problems there, they're trying to just make a point to you that the ln is it's the same thing as the logs that we talked about in a previous section in this chapter. And so all those log rules hold. This is just a log base e, so the log rules hold. If you remember, if you've got two of the same bases, and ln is base e, it's just a funky way of writing it with an ln. And you've got the same base, and you've got two things added together. The product rule says you can rewrite those as one log, and you would just say that's ln of 3 times 4. And again, if you remember, the reason this works this way is that logs are actually exponents, and so we can actually the proof of all this stuff comes back to the fact that these are exponents, so they work like exponents. So what is 3 times 4? It is 12. So this would just be ln 12 here. All your old rules work. I'll do 21 just because it's got an well, yeah, it has a little exponent, and you go, what? And then look at it. You'll see what I mean. This is a 3. You're adding all this stuff together. Oh, not ln 3, it's just a 3. They're being all tricky again. First of all, you know that this 1/3, if it was out front, was on the 8. So that's ln 8 to the 1/3 power plus ln 5. Now, we know from previous sections that they have done something with this. When we see a constant there, they're not going to leave it as a constant. How could I get a 3 off of a ln? Let's think about that. Let me come down here and just kind of have a little workspace. I wish I had done this on a separate. Log base e of some number, let's call it b, since we know this is log ABC, is equal to 3. So if we change this into exponential form, e to the 3rd power, I'm thinking I, C, a B, I'm just not going to write it down, e to the 3rd power is b. Okay, so log e cubed is 3. So that's ln e cubed, isn't it? Okay, So I can write ln e cubed, and now that we see it, we go, oh yeah, that's what it was, because those two would cancel out and leave a 3. Now I can put all this together, but let's simplify a little bit more first. This was just me figuring stuff out down here. Now ln 8 to the 1/3 power, that's the cube root of 8. And the cube root of 8 is 2, so this is just ln 2 plus ln 5 plus ln e cubed. And the product rule says we can, since it's the same base, we can take all of these terms and write it as one log, and it would be ln 2 times 5 times e cubed, right? Because you would multiply all those things together. That's what the product rule says. That would be ln 10 e cubed. I know it's kind of hard to read, but if you're following along, you should be listening to the video audio too, not just following along and writing steps down. So it's ln 10 e cubed. Okay.